Hello.
What?
Yes, so I can see that I can hear myself from the YouTube link. So could anybody please write in the chat if they can hear me? Just before I say something. Yeah, I got thumbs up, so it seems that we are through. So just to show that we are the three groups giving this talk today. It's always a bit difficult to talk through online meetings. So yeah, so we're actually delighted to have Isaac Abrahamsen give a talk today on repeatable builds with this tool called Farmer, which he will explain a bit about. So just before we go into that talk, we will have a bit of introduction of our four groups or three groups. Probably not that much, because I'm guessing that even though we are three groups hosting this meetup, people arriving from the different ones probably know each other, right? So the one that I'm the organizer of is the Functional Copenhagen's meetup, which is a meetup that focuses on a functional program with a functional flair. CPH.net is the one related to the .NET user group in Copenhagen, and Azure.net is also related to Microsoft's Azure, which is the cloud platform that Microsoft has going on to compete with both Google and Amazon. And the talk today, since it's very much related to Azure, but also has a flair of functional programming, and of course because it's relying on .NET, I thought to myself that it gave sense to combine these three groups to actually host Isaac on this meetup. So before Isaac will jump into the talk, and I think we can maybe start a bit earlier. If Alberto, he can do this talk with regard of Pandora and the journey to the cloud. So Alberto, if you would share your screen and probably share a few words. And please, in the chat, please tell me if you cannot hear Alberto, because maybe I have unmuted the wrong thing. Or muted the wrong thing.
Can you see the presentation?
Yes.
The slide?
We can see it, yes.
Cool. So I will start. First of all, I'm Alberto Mantia. Nice to meet you all. I'm the manager of engineering of NQA in Pandora. I want to say that I was really happy when Ramon asked me to present the tech achievements of Pandora during the last couple of years. But before to start, let me introduce a bit, my background. I have a bachelor in computer engineering and a master in computer science, and I've been the tech developing application for the last 10 years. I started as a junior Java developer, and I moved on to the dark .NET world, and then I stayed with .NET and Microsoft for the remaining of my career. And I covered different roles, and for the last 4 years I've been managing a team of developers and software engineers to build application both web and desktop application. So I work for Pandora. Not sure if everyone is aware of what is Pandora, so I will give a bit introduction of the number one jewelry brand in the world. So Pandora is a company that was founded in 1982 as a jewelry store, and has grown exponentially over the years, and Today we have 26,000 employees globally. We sell 85 million. We have already sold 85 million pieces of jewelry. We recycle. Our jewelry, come from silver and gold that are from recycled resources. And we are present in more than 100 countries with more than 7,000 point of sales. Essentially, Pandora give the voice for people that loves the jewelry world and to affordable prices. So I personally part of the digital hub of Pandora that is that represent the technical part of Pandora, the engineering part. Was created last year with the goal of creating a community of makers and doers, being the center of the Pandora digital and technological creativity. Apart from being a community, we have also a physical space with that is arranged more as a startup style, even though Pandora is a clearly an enterprise company. In this space, we have more than the one department that works together to push Pandora technological innovation boundaries forward. And it's mainly divided in 4 areas that are the e-commerce part, where we take care of the website of Pandora and the operational performance, and we deliver on our promise to deliver the jewelry to our customer. Then we have the advanced analytics part that is more as a data-driven agenda. So we do create a lot of machine learning algorithm on the data that we gather from all our system, from the stores to personalize the experience of our users, both in the store and the digital part of it. And we have the digital and development, digital development and retail tech that is focus on digital and tech solution to enhance the experience. So there is a bit of overlap between advanced analytics part and the digital development, is because one feeds the data to the others, right? So while in the first one there is a lot of analysis and modeling, the second one is more the interaction, how we are going to do that. And the third part is the marketing technology that is still is a continuous of action from the first 2 parts that is about our brand, our products, how do we engage with the customer. If we go through SMS, emails, we go through the website, chatbot, and all the other tech that we have available in Pandora. So now that you know a bit about Pandora and the digital app, let's go back in time and focus on 2018, when this journey of Pandora started. Pandora, is a retail company, so mainly revenue goes through the store, the physical store, but a decision to have a shift towards the digital world as pushed forward the digitalization of Pandora. In 2019, there were a lot of localized solutions, for each market, engaging with the local vendors to create a solution that fits the business case that each country or each market had to deal with. This ended up with having a lot of solution and application on the bare metal or in some servers in data center, scattered around the world with a pretty complex solution landscape with huge operational expenses for maintenance or running cost. So all these those solutions and this scattered landscape and the cost. So pushed some initiatives from Pandora with the journey towards cloud services. So the recognition of this cat landscape has made aware that Pandora had to move towards innovation in technology. So in 2018, through a strong partner of Pandora, then there's been a big transition of moving all those server application databases, any kind of layer towards Microsoft Azure. This is of course cannot be done alone, so they leverage a strong partnership with Microsoft in order to achieve this goal. And Microsoft was, had an important role and still has an important role in this transformation because they've done this in the past with the other companies. So they have the experience on which are the steps that a company should go through moving from on premises to the cloud. Such a big transition, of course, needs to go through different phases, and in 2019 the focus was more on lift and shift, right? So creating a lot of images of the servers or the databases or the application and moving them to the cloud, so spawning virtual machines and uploading the information we had there. Of course, this goes along with a lot of security, networking, access control, federation, so that still our landscape is old and is reliable and secured, right? Of course, this was not enough. So this was only the first step to push innovation in Pandora. And so in 2020, we started to refactor or decommission a lot of those services that were just lift and shift, right? So we started to leverage all the services that Azure provides in the cloud, right? Like web apps, API management, data lake, data factories, password protection through Key Vault, monitoring tools. We introduced also NoSQL database through Cosmos. All the application start to have not more .NET Framework but .NET Core, introducing some event in our landscape, leveraging Service Bus, Event Grid or Event Hub, depends on the case. And in terms of analysis of data, Databricks and Spark that work really together in the Azure ecosystem had a strong influence in our 2020. All those services, they don't come for free, right? Because during 2020, if you are aware of the bathtub curve, at the beginning you experience most of the problems or most of the early issues, implementing and moving towards those elements. So 2020 was a really push forward for in terms of innovation for Pandora, addressing a lot of those early issues in the transition, right? And I can say that at the end of 2020, we still have a lot of our integrations and based through file transfer, but yet we have already some applications in production using most of the service that you see here, right? So using data lakes, analyzing data with Databricks, web apps that scales accordingly to load. So a lot of CI/CD pipelines. So all the DevOps concept that ingrained in using a lot of those systems, we start to apply them and start to see the benefit of having a reliable, scalable system that is monitored, alerted in case of problems. And so we did a lot of this in 2020. But this is not over. We are in 2021, and still we have some monolith that needs to be translated in microservice architecture. We have a lot of APIs that are interacting more like a point-to-point application, so or that they do not interact in real time. So we are now upgrading those interaction using an event-driven architecture, creating a service bus and allowing system to react in real time with what happens in all the different systems. That can be an order that a client does on the website, can be a user creation or something that happens in the store, a cart that gets abandoned from the user. So we are pushing different architecture for new architecture for Pandora in our landscape. And last, that is it's something that we also start to look, but we have not yet cracked, is the bottom one, that is a data mesh principle and architecture. Having data as product. We already started to see how not only the technology behind, but the organization should change in order to implement some of those architecture. And so this definitely it's a journey, and there is a lot of push from Pandora to innovate in technology, and this is where the tech vision of Pandora lies at the moment. So as you probably can see, we are also having a lot of job ad out there. We are looking for talent, tech talent that will help us to build all the tech using Azure services and those new architecture. So if you are interested in work with those services and those architecture, feel free to reach out. I'll be available for questioning, and feel free to reach out also on LinkedIn or through Ramon, the organizer. This is about Pandora. I don't have anything more, so I'll leave this to you, Isaac.
Yeah, thank you very much for the talk, Alberto. I think I got much wiser of what I actually do on a daily basis, so thank you very much for that. And I hope a lot of people see that no matter which business you actually are in 2021, everybody is going into the cloud in some way, and everybody is doing some really fancy stuff with a lot of tech words. So Pandora, as you can see, is another one of those. Yeah, and I think it's time to the man of the hour, Isaac. So if you would share your screen so we can see Farmer in action, which is a pretty cool tool.
Let's do it. Can you see my screen?
I can, but it takes a bit of time to get to the YouTube. Yeah, I can see it now on YouTube as well.
Yeah, okay, good. And I'm assuming that the audio is all working. So, yeah, I'll leave the YouTube window open on the side as well, just so I can see any questions. But if you're watching that one as well, Ramon, then obviously if any questions do crop up and I miss them, then please do just let me know.
Sure, no problem.
Great. So thank you again for the invite. It's always fun to talk about this sort of stuff because we use Farmer almost on a daily basis at the moment, and something that's certainly making our life and some of our customers' lives a lot easier. And it's interesting, as you mentioned before, we've got several user groups sort of participating in tonight's talk. So hopefully there'll be something for everyone, whether you're coming from the sort of functional background or the cloud background, or just the .NET background. Might make, I'm hoping that you'll all perceive it in different ways, but there'll be something to everyone, really. I'm going to try to not talk for too long on the PowerPoints. maybe 30 minutes max, and then some demos, and then probably back to PowerPoint for a few more slides. So I'll start then. Great. So let's get the other window open. Excellent. So just a bit about me. So yeah, my name's Isaac Abraham. I'm the founder of Compositional IT. We're a consultancy that do F# and Azure. We do training, support, outsourced development, those sorts of things. We're based in the UK, although I'm actually based in Germany. So you can tell from my accent, I'm not German. I'm British from birth, but I've been living here for a few years now. Been using F# for probably 5-6 years, full time, but .NET developer since the very, very early days. .NET 1.0, really like the very first version of Visual Studio sort of thing that supported .NET. So my background is probably more C# than F# in that regard, and more OO than functional. Obviously, I can't easily do a show of hands as this is sort of an online talk, but I wouldn't mind just for my background, if you do type into the chat window, just sort of what your background is, sort of F# or Azure or .NET or functional, Scala or Haskell or AWS, just so that I can have a read through that in a minute or two and just sort of get a feel for the sorts of background that the people that are watching this right now are, and that will help guide me towards talking and focusing on the right bits really. So the agenda will just be about a kind of a review of how we create infrastructure in Azure today. A look at ARM templates, a discussion of why we started the Farmer project, some demos, and then just a kind of a how do I get started and what do I do next if I want to actually start using this. So I'm going to just talk 5 minutes or so maybe just about how people tend to be doing deployments in Azure today. And I guess this doesn't only apply to Azure, that AWS and GCP, I imagine, as the two other main cloud providers, have a similar kind of alternatives or ways of doing things, although in Azure it's probably a bit stronger from what I can see in terms of where Azure tends to push people. People often talk about this thing of CI/CD. When we mention that, everyone is talking about, I'm going to build my code in, GitHub Actions or Travis or, Azure DevOps or whichever your choice of sort of build pipeline is. I'm going to run unit tests, I'm going to build, I'm going to package the code, and then I'm going to deploy the code and run it. But people aren't talking too much about doing that for infrastructure, really. It's almost tended to be that when you get to that point, it's, we'll do that as a one-off, probably manually in some cloud portal or website, and people tend not to be doing the infrastructure at the moment anywhere near as much. And I think there's a few reasons for this. And I kind of came up with that it's basically just too costly and expensive at the moment for a lot of people to do that. And the way I sort of looked at it is how do we, how is, particularly on the Azure side, how is it being marketed? How are people describing, both at Microsoft and outside of Microsoft, as how to deploy infrastructure? And there's a whole bunch of ways of doing it. Probably the most common way that I see customers today using Azure is to use the portal, which, it's been through a number of different iterations, but it can do, a reasonable amount of things. It can do probably more than nearly anywhere else. And you'll see most demos and guides and walkthroughs today about go into the portal, click this button, click that button, and you'll get some resources. Super easy to get started. Problem, of course, with this approach is, you're clicking buttons. It's really not repeatable. It's not going to scale at all. It takes time to do. And interestingly enough, some services in Azure that are kind of code focused don't really let you deploy code through the portal. So the app service is like the main place where you can deploy web applications in Azure. But there's no kind of wizard that says, I want to create a web app and deploy this code. You have to sort of deploy the infrastructure and then look at how to deploy code, whether that's via FTP or web posting a zip file up there and so on. And it doesn't really tie the two together. Next one I've seen quite often is using Visual Studio. So that's like Microsoft Development Environment, Windows only. There are other ones that are cross-platform, but Visual Studio is Windows only. You can sort of say, I want to deploy a web app, and right-click the project, you publish, and you get this wizard. And again, easy to start. It can do both infrastructure and code as well, which is good. Again, totally not repeatable. It doesn't scale. Again, it's also got limited use cases. By that I mean you can only use these sort of wizards that have been sort of given to you by Visual Studio. So in this case, the screenshot had 14 examples. So obviously it's not really that extensible. It's not going to be flexible enough to deal with many use cases. Yeah, so obviously this is not where I think we want to be. So then we come to these kind of code-focused deployments. And there's a whole bunch of different options that Microsoft and other parties give at the moment. So we've got sort of PowerShell, which has got this thing called the Azure Commandlets, or the PowerShell Commandlets for Azure. The Azure CLI, which is a cross-platform as well, set of commands where you can essentially do effectively everything in the portal, but via a command line interface. There's a set of .NET APIs. And underneath that, you've got this REST API where you can literally just hit HTTPS endpoints and sort of do the same thing that these three are doing, but just directly with HTTP and JSON. And then at the very end, you've got this thing called ARM templates, which is where I'll talk about in a minute. But this is essentially a declarative document that you can deploy into Azure that basically says, this is what my infrastructure is going to look like. Please go ahead and do it. And then you've got a couple of sort of third-party options, Terraform and Pulumi, which have two different approaches to solving the same problem as well. And we'll talk a little bit about them in just a minute. So this is not an exact diagram, but it's something I think it's a simplified version that is worth looking at. So you can almost think of the REST APIs as underpinning those three sort of PowerShell, Azure Client, and the .NET API. And then you've got this, you've got things like Pulumi and Terraform that have their own kind of state services that they manage for you that understands things like, I did a deployment 5 minutes ago, I've now redeployed the same infrastructure, what needs to change? And then it will generate a diff effectively. ARM templates go through this Resource Manager API. It's essentially the same sort of thing. You can upload a JSON document of your resource infrastructure. You can then upload another version of that document and it will do a diff compared to what is actually deployed and add and remove the appropriate infrastructure to make it reflect that JSON document. There are some good things about ARM templates in terms of this JSON document. One, it's 99% of the time it supports what are called idempotent deployments. So you can take the same document and put it in a CI/CD pipeline and just run it every time. And if nothing needs to change, then it's completely harmless. It won't do anything. It supports for loads of Azure resources, basically virtually all of them. And you can basically support virtually every property that every resource can handle. Cross-platform, it's just a JSON document. So, it works pretty much everywhere. There's really not too much to it in that regard, although we'll come to that later. There's a bit more to it than just a JSON document. Cross-tooling support, as I sort of touched on just now. And it's also got this nice ability to do what's called like deployment recording and auditing. So every time you try and do a deployment, the portal will record it and you can see at what time did you do this deployment, what did you upload, what did it do, and so on and so forth. So that's all well and good. Why wouldn't you want to use ARM then? So there are kind of two, I guess, use cases for this, or two personas. So if anyone is actually using ARM templates today, there's one person that says they're using Azure, at least in the YouTube group. So if you're using ARM templates, this is typically the experience that I've observed, particularly with not only with our customers, but partners of ours, is the deployment experience is very positive. We can deploy this ARM template. It's JSON. It's relatively quick. It's idempotent. It works quite reliably, which is great. The pain point is really about the authoring experience. So getting from nothing to here's a JSON document that has everything I want to deploy. That's the bit that most people find challenging. So that's sort of one half of this story. If you know ARM already, I see people often on Twitter and other forums sort of, I got my ARM template working, I deserve a beer sort of thing, you know, or I deserve a day off now. I'm super happy. It's a really satisfying experience once it's working. For people that are not ARM experts, it's a very different story as well, though, is people tend to just give up. They want to do things the right way. They'll then simply say, well, actually, I've heard about this. I've seen someone on Microsoft and the Azure team talk about ARM templates. Let's try it. They'll spend half an hour with it, an hour, and then they'll just give up and go back to the portal. Unfortunately, this is what we see nearly every time with people that are not Azure experts and certainly not ARM experts. We wanted to really target, in effect, both parties, but particularly the right-hand side, so that we could say that we make it easy for those people to start doing the right thing. If you're doing ARM templates today, these are the sorts of patterns that we see people using to try and figure out and author these templates. Firstly, they'll go to what's called the Azure Samples 101, which is a GitHub repository, which has got more than 101 samples of different kinds of resources and patterns and topologies. The problem is you'll probably spend, you'll find a sample that has part of what you want, and then you'll try and extract that bit of the JSON that you need for your template. So maybe you want a storage account, and you might find something that says, app service with a storage account behind it. And then you'll go into that JSON file, you'll look through GitHub, try and copy and paste the bits you want. Maybe you'll look on the community. So you'll look at Stack Overflow, look on some blogs, see if there's someone who's been through the same problem that you're going through. Hopefully someone has been through that pain and can solve it for you quickly. You can also, in the portal, you can manually construct some template, some resources, and then you can try and reverse engineer a template in the portal. The problem is that doesn't always work. And if it does, it's almost certainly not in the format that you need. So it's still not, it's definitely not a one-stop shop. Use things. It's not set up for like, these are the properties I need to do. It's very much a reference docs rather than wizard style, these are the bits you need. This is how to achieve things. So I would say expensive to create and maintain. And the maintain bit is something that often people overlook. If it's expensive to create, there are probably two things that you're going to have to think about. One is maintaining that template over time as you make changes, and two, the fear factor that someone is just going to be too scared to make changes to this template over time. Error prone, it's just JSON. It's pretty easy to get things wrong. It's weakly typed. It's just the JSON document. And we'll see how ARM sort of gives you some type of typing, but it's kind of a hack really. And this is an important one. It's, I think, the wrong level of abstraction. It's very low level of abstraction in terms of template and in terms of how we think about Azure resources. And it's ultimately somewhat limited as well. There are some things you can do with it that are great, but it's not necessarily really the right way, I would say, of doing things. And there are some things I think that are really ugly, really painful. So the amount of documentation that you need to sift through to create even trivial templates is not great. And the documentation, I have to say, on the official docs, it's really not great. It's outdated, it's unreliable. You'll sometimes even find contradictory documents. So you'll find one page that shows you one way of doing it and another one that shows you a different way. Which one should you use? Why should you use which one? Not always clear. It's also inconsistent across resources. So by that I mean that the schemas, the ARM template structures for each resource is done by a separate team. So the app service team will define the app service schema, and the storage team will define the storage schema. So you'll often have different ways of modeling and representing certain common patterns. And it's slow to validate and fix. So this is often another part that people overlook is you've created some JSON document. Maybe you've got some notional support from the tooling to tell you it's right. You'll deploy it, you'll wait a while, and then you'll come back with an error that says, sorry, you didn't supply this parameter, or you didn't set this correctly, I can't do this. And that turnaround time can be very slow. It might be 30 seconds, but it could be 30 minutes, depending on the type of resources you're creating. So there's kind of pros and cons to that, but it's generally a slow turnaround cycle. So Microsoft, about a year or two ago now, maybe 18 months ago, they started realizing, let's improve this with some tooling. So they created what's called a language server in VS Code that can try and give us some level of language support. And they'll give us some code completion and code snippets and schema verification. Everything was designed to try and solve this problem around ARM. It, to my mind, didn't really work. It was more of a band-aid. And I think, to be fair, Microsoft really knew this, I suspect, that it wasn't going to solve the real problems. Firstly, these code snippets and language server, it's a VS Code only extension. So if you're using Visual Studio Code, then great. But if you're using Rider or Visual Studio or Emacs or whatever else, Sublime, you're out of luck. You can't use this tooling. The schemas are generally outdated and they're not that powerful. So the level of type safety and confidence you'll have is commensurate with how well updated these schemas are. Discoverability is not great. Code snippets, I think, is really a band-aid, simply because the answer is not, to my mind, let's make it quick to write lots of code. I'd rather say, let's not need to write lots of code in the first place, and then that's much better. And lastly, again, JSON, it's not a great way of trying to define these documents. Ultimately, declarative documents work to an extent, but sometimes you very quickly realize you can't use that approach. And more than that, you need to do all sorts of crazy things within JSON for ARM templates. There's almost a kind of a pseudo language embedded in raw strings that ARM templates support to do things like adding or concatenating strings together. It's really not great. So yeah, I don't think this is the way forward. I think we need to really rethink how we work with ARM templates. And to be fair, I'll talk about this we want something that I think that's definitely quicker to author, easier and quicker to understand and read about and reason through, cheaper to maintain, and generally more powerful as well. So those were the kind of what I saw the problem space with ARM templates. So what is Farmer? So the shorthand is Farmer is a library that makes repeatable Azure deployments easy, or easier depending on your perspective, but at least less painful. The kind of long-term vision of the project, I would say, is to make it as easy, if not easier, than deploying in the portal. Now, we may never get there, but I want it to be something that someone who's never done it before can create resources without going even into the portal. There's a longer way of doing it, of describing it, which is this. So it's an easy-to-learn library for rapidly authoring and deploying entire architectures through ARM templates and Azure CLI. Now, those two things are important. So Farmer does not sidestep ARM templates or the Azure CLI. It sits on top of them. So you can think of it as a kind of a veneer on top of these two libraries and capabilities, kind of brings them together and gives you a single coherent API on top of both. So what does it give us? So one, you can very, very quickly create and author ARM templates. Two, you can deploy them as well very quickly and easily. You don't have to though. If you're someone who's using ARM templates today, you can continue to use ARM templates tomorrow and use your existing deployment strategies. So if you're using Azure DevOps or you're using the Azure CLI or PowerShell commandlets, you can carry on doing that. It's no problem. What I did want to do is help us focus on what I consider high-level concepts. And I'll look at an example of that today in the demo, but really at the level that we think of abstractions rather than necessarily how ARM exposes Azure resources. But I still wanted to give us escape hatches. So if you need to drop down a level and do something a bit lower level, you can do as well. And we'll talk about that as well. So I would say there's three kind of personas that Farmer uses. One is people that are new to Azure, that maybe just don't have that expertise on ARM. Two, people that are using ARM already, but understand that there are ways that we can improve that experience. And three, what I call dynamic deploy. So that is really about people that are writing typically software services where you are programmatically deploying resources. Maybe you have a platform that is doing some kind of big data compute, and as part of that compute, you want to spin up 25 nodes on AKS or maybe virtual machines or whatever, run some code, get a result back for your customers, and then decommission those resources. So for that sort of thing, Farmer is really good because you can parameterize through code how you want to deploy your resources and do this entirely in a strongly typed language. Because it's F#, if you're already using .NET, you can quite easily call this from C# if you're using, or if you're doing F# already, you can tie this into your standard F# code. So you could have something where it's just, I have a web app. If someone hits this endpoint, we're going to do some spinning up of resources. We'll do something, get a result, and then carry on and doing our standard processing. So for those kinds of things, it's very useful. A few of the features, and then I'll jump into a demo. So I think it's highly productive. It's type safe, or as type safe as we can do. We've certainly made some, I wouldn't say compromises, but some design decisions as to how type safe we want to push that. We want to make the syntax very simple, but at the same time, we also want to make it safe as possible. Runs on .NET Core. It's open source. It's commercially supported. Sometimes people often think of open source and commercial support as almost you need them, but it's also an open source package, so you can use it for free if you want and look at the code and so on. We simply don't recommend it for production runs without support, effectively. And it's extensible, so at the end of the day, you can add your own modules into Farmer. You can add your own resources in. You can even add your own sort of what I call topologies. So if you decided you had a cluster of some specific set of resources, you can almost hook that into Farmer as your own abstraction and just use it alongside the other ones that are already built in. And at the end of the day, Farmer just deploys ARM templates. So from a security or a enterprise level sort of thing, Farmer just emits ARM templates. So there's no need to be worried that your security or infrastructure teams have got a problem with this, because it is just ARM templates at the end of the day. One architecture diagram, and then I think we're almost done. So at the top level of Farmer, we have what we call builders, which are what I was referring to before, this higher level abstraction of a topology or a way of defining a number of resources. So in ARM terms, or Azure terms, a web app may boil down to a server farm, web app, and app insights, so multiple low-level resources. And then from there, we basically make what we call an in-memory template, where we have the actual resources, parameters, and outputs, and then we generate an ARM template. Optionally, you can deploy to Azure through Farmer as well. If you do that, we can also hook into what we call post-deployment tasks, where we can do things for you, like deploying your application code as an atomic action, or what appears to be an atomic action at least. So I'll give you just an example of a common ARM task and how we might do this today, and some of the challenges that you might face. And then I'll do a quick demo of this, and then I'll move on to a second demo, which shows virtual machines as well. So this is kind of a typical scenario that I see today, which is creating a storage account, creating a web app, making a dependency between the two. So imagine that I've got a web app which is going to create data in a storage account, linking the two together, maybe adding an app setting or an environment variable on the web app, and then parameterizing the whole resource. Now, what I'll do is, I'm not going to do this by hand in ARM, but I will do it in Farmer and show you what it emits, so you can sort of see the side-by-side of the two. So I'm going to jump into VS Code. Ramon, if that doesn't look clear enough or something, please just tell me, and yeah, I'll make the font a bit bigger.
I would say at least from my 720 screen, it seems perfectly fine.
Okay, good. Obviously, in the YouTube channel, if you guys think it should be a bit bigger or not, just let me know. So I'm going to start by just creating a new .NET application. I'm going to create a new console app. So I've got .NET 5 installed here, but Farmer is Net Standard 2 compliant, so you can use it with older versions as well. And the only extra bit I'm going to do is say lang F#. So I think I touched on this already. So Farmer is indeed an F# project. You can write plugins in C#, but --lang. Yeah, you can write your own plugins, but the main core of the language or the app is in F#. So I'm just going to run .NET Watch Run, which is basically a loop in the .NET SDK that will start an application, and then every time I make a change, it will stop and start it again. And that will allow me to just relatively quickly go through a loop where I can make changes, and you can see the outputs in terms of ARM. So this is the starting app you get with .NET New. So I'm just going to remove all of that. And in fact, I'm going to stop now already, and I'm going to add the Farmer package. So I'm going to say .NET add package Farmer. So that's downloaded the NuGet package for Farmer, which is there now. And I'll rerun the app. And we won't see anything, obviously, because there is no code. Okay, so I'm now going to actually start writing my first Farmer template. So I'm going to open the Farmer name. So I'm going to say location is location dot, let's say, North Europe. And then I'm going to generate an ARM template from this. So I'm going to say template, and I'm going to pipe that into a function called QuickWrite, which just takes the name of the template that I want to generate. So Copenhagen. I'm just going to put this side by side so we can see as I'm going through this what's happening. So I've got my first template. Doesn't have obviously much in it, but this is an empty JSON, an empty ARM template, and I can already see that Visual Studio Code has realized that this is an ARM template. It's trying to load some schemas, and on the left here, I'll even get an outline of the template. So it is indeed a valid ARM template, but there's obviously not much in here. So I'm going to start by creating a storage account, which is one of the more popular resources in Azure. You'll see that the syntax here looks relatively similar almost to JSON, in that we have this kind of curly brace and kind of key value syntax. I'm going to create a storage account, and I'm going to say name equals Isaac storage, and then I'm going to say in fact, let's just leave it at that for now. And then I'm going to add this resource into the template. So the storage account now. So now we've got this code generated here, which takes care of a lot of these things confuse a lot of people when they're starting with ARM. Like, I have to know what API version is possible, and I have to know what these kinds are, and I have to copy the location to every resource I create, and so on and so forth. And to set the SKU, well, it's not inside properties, it's at the top level for some reason. You know, these things are SKU. Should be able to say storage.skew, and then I have the list of different storage kinds. So I can change that and hit save, and now that will cascade down into the template. So I'm now going to create a web app, and this is where things will get quite a bit more fun. So I'll say my web app equals web app, and I'll give it Isaac Web. And I'm going to add another resource. So add my app. And we can indeed actually simplify this to make this a list. So I can do instead. I'm going to add two resources together. And I'm just going to actually turn off one setting. So you can see here we get these keywords that I can add in. I'm going to switch over to the template, and you'll see that we've got the storage account. We've also got what's called a site, a farm, and a site extension as well. And if I view this, there's a nice extension in Visual Studio Code called the ARM Template Viewer. So this actually automatically will give me a graphical representation of the resources that I've created from here. So the web app has actually three components: the site, which is the actual code where your code resides; the farm, which you can think of as the server that's hosting the site; and then an extension, which is something that you can add in. It's kind of an extensibility module to the app service. In this case, it's a logging extension that we automatically put in out of the box. Now, if I turn on App Insights, this is going to get even more complicated. And we'll see that there's actually now going to be a fourth resource that's been added very shortly. We have this components one. And if I turn on labels, you'll see that we actually have naming conventions that have been based on the name I gave here. So I said the web app is Isaac Web, and then the farm is that name dash web dash farm, and the App Insights instance, which is a kind of an app logging framework and service in Azure, is also set up there. And you can see from these arrows that we basically set up these dependencies so that Azure understands I can't deploy the web app until the server farm has been created, but I can't create the App Insights instance until the web app until the AI instance is made, but the site extension is dependent on the web app, and the storage has no dependencies at the moment. And if you look inside this, I had 20 lines of code here. This is already now up to 130. Some of these things are, just a bit more verbose than I think they need to be. But there's also things like, if you want to correctly, out of the box, get App Insights working with a web app, you have to set these 7 or 8 different settings with these values. And these are the sorts of things that if you've not done it before, you'll need to spend time looking online, trying to figure out what's going on, Googling it and so on. So we do all of this for you so that out of the box, you can deploy an ASP.NET web app and you'll get this logging working out of the box for free. So what I'm going to do now is the next thing I want to do, which is I'll add a setting in, which is effectively, imagine we wanted our web app to have the connection string to the storage account. Now, there are many ways of doing this. One way you could do it is to say, well, actually, we'll deploy the storage account and we'll copy the setting into the web app after we've deployed it as an app setting. Or maybe you'll say we'll actually store it as a config file or paste it directly into our source code. Obviously, these are the last things that you want to be doing. In Farmer, we make it easy to do the right thing. We make it easy for you to never have to persist any secret at all. So I can say I want to add a setting, which I'm going to call storage key. And the name of it, and the value of it rather, is going to be mystorage.key. What have I done here? This is actually going to create what's called an ARM expression. So let's go back here. And you'll see we have a setting here called storage key. And this is where you get to the low levels of ARM, the bits that people really fall foul on and really struggle with, is we're embedding this kind of ARM dialect where I want to concatenate these and then get the very first one, and then concatenate it to this other string. And now if this is complicated and you're looking at this thinking, well, what is he talking about? That's kind of my point. I don't really want to have to know that. What I do want to know is I want to step this setting in my web app to that key. There's never any secrets here. The only thing that you'll see is actually this expression, which will be evaluated by Azure at the point of deploying. So there will never actually be a secret at rest in your code base. If I jump back to the ARM viewer, you'll also see now that the storage account has been linked to the app. So now it knows there's a dependency. I can't create the web app until the storage account is created because I want to create a setting that's reliant on that resource existing. So again, this is something that catches a lot of people out. They don't do the dependency. Sometimes they'll get lucky and Azure will deploy the web app first. Sometimes you'll be unlucky. The storage account will go first, or vice versa. The storage account will go first. You're lucky. If it doesn't, the deployment will simply fail and it will say this resource doesn't exist. So we try and simplify a lot of these things to make it easier for you. Right. I'll talk a bit about parameterization and variables. So if I want to make a setting here, like, I don't know, let's say Isaac, hello world, or something like that. Well, this is just F#. So I can do things like Isaac plus. And this is just F#. So let's say, so I can just do normal arbitrary F# code in here. Totally fine. And you'll see there, we've now got a normal string in there. So we don't have to use this concat stuff. It's easy to do this. In terms of parameterization, that's another interesting one. So imagine I wanted to have dev, test, prod environments. Well, really not too challenging to do that. What I could have is something like a function that's going to create me my infrastructure. And to do that, I don't need refactorings or anything like that. I can say create environment, and let's make a parameter called env_name. So that's the name of my environment. Indent this, and now I've got a function that's going to generate me one of these ARM templates. And here, I'm just going to add on here. Let's do it this way, $env_name. So this, if you've used C# before, you'll see this kind of syntax. It's called interpolation. So I'm just injecting that value inside the string. And I can do the same here. So I'm going to say env_name as well. And now I can create dev environment equals create environment dev. So you can imagine this running as part of a CI/CD pipeline, where maybe you're running this environment 3 times, and this is just an environment variable that you're setting in your CI/CD environment variables. So now we've got our resources, Isaac Web Dev, and of course all the other resources are going to be named based on that. So Isaac Web Dev AI. And this helps you have a consistent naming structure as well, which makes it much easier to see what's going on, which I think is also a good thing. So I think that's almost about what I really wanted to talk about at a high level. If you've got any questions at this point, please do flag them up. Otherwise, I'll kind of jump onto a second demo, which is about virtual machines.
So I just have this. Isaac, could you mute? Yep. Or is it me? Yeah. So I just have this question with regard of since F# is this top level programming language, I really like when I define my templates is that I can only point for my ARM template to my application and to my storage. So you need to define like the storage and the application before you can bind them into this ARM template at the bottom. So of course you can use let and end, but that's a bit more complicated than most people use. But just by using the language as it's intended, you can ensure that you don't do misconfiguration out of the box. I really like that feature.
Yeah, absolutely. So I couldn't do that, for example, because of the nature in F# that everything must be declared before you call it. So you can't do that. And you obviously, yeah, because it's generally strong typed, you know, if I type that in, then I'll get an error there that doesn't exist, and so on and so forth. You can actually, with many of these resources, you can, well, in fact, with all of them, if you've got a resource that lives outside of the ARM template, we still allow you to create a handle to it. So maybe you've got something like a shared storage account. In that case, and you want to maybe use it as a dependency on here or something like that, we do allow you to create a kind of a weak link to one of those accounts. And then it just doesn't have to necessarily be deployed as part of this. It might already exist. So we give you some escape hatches as well on that front. But most of the time, this leads you down the path of creating a resource group with everything in it in one place, which I think is much better than having resources scattered around, or multiple environments in the same group or something like that.
Yes, I can confirm that that's possible, but then you put in an extra complication into the mixture, because then you can have these cyclic references that you usually get when you're just doing it in JSON. So I try to avoid that as much as possible.
Yeah, that's that's good practice, I would say. So yeah, good. I think yeah, let's jump back to the slides since I'm not seeing any questions in YouTube, and then we'll jump back into code in a second as well. So I want to show one more example, which is a virtual machine, which something that I think should be pretty easy, particularly for people that are coming to Azure for the first time. I think a common scenario will be more of a lift and shift. I want to create a virtual machine and deploy some code onto it. So VM in ARM it's not just a single resource called virtual machine. You actually need 4 resources. You need the virtual machine, you need a VNet, you need an IP, and you need a network interface card. As far as I know, this is the minimum deployment number of resources you need. You've also got all these other considerations, like you've got to know about the virtual networking, you've got to set up public IP address, you've got to think about the storage, because you've got disks behind it. You might have an OS disk, the data disks, which virtual machine image do you want? And then you've got to think about how you want to deploy your resource as well. So the virtual machine, where do you store that password? Do you put it in the ARM template? Well, you need to, but how do you do that in a way that doesn't expose the actual resource and that password later on? So I'm going to jump back in here, and I'm just going to undo this. So I'm going to actually comment out that for the minute. We'll come back to that in a minute. I'll show a couple more features, and then we'll move on to any other Q&A. So I want to create a virtual machine. So I'm going to say my virtual machine equals VM, and I'm going to open up the console here because I'm deliberately going to make this fail. So I'm going to say Isaac VM, and then I'm going to add that over here. Save this. Now, this is actually going to fail. It's not even going to generate the template. So I've actually got an exception here. You must specify a username for the virtual machine Isaac VM. So we actually have, because you need a username for this machine. So I'm going to say Isaac, and then I'm going to save that again. And what you're going to see, this is actually going to work now. It's going to compile. The thing we're going to have done is when I look at the password, let me just search for that word password. So we've got a flag here, which is admin password, and I'll talk about the other sort of bits that we've actually created in a minute. But we actually don't emit the password. Well, you can't have, you haven't set it here, but we actually make it a parameter that is passed into the template. So if I look right at the top here, so we actually have a password for Isaac VM, which we've automatically generated. And this is a secure string, which means that the ARM template will know never to actually persist this in the ARM audit logs or anything like that. It will never be stored at rest anywhere in the pipeline. So you could theoretically have this running as an environment variable that's come through from your CI/CD pipeline, and again, never stored at rest in your code. Now, I'll just talk briefly about what we've actually created here. So again, I'll jump to the ARM viewer, and you'll see indeed that we've got those 3 other resources. They've all been hooked together. And you can do a lot of things with this. So I can say things like, I want to have, let's change the operating system. So if I want to change the OS, I can then see what argument is needed there, which is a image definition. So let's see if I can remember this one. VM dot, there you go. So on VM, we suddenly have these OSs over here. So I can say, oh, actually I want it to be Ubuntu. And then we've got that. If I want to add some disks, I can add a disk. I can choose whether it's a slow disk or an SSD, how big it's going to be. Now, interestingly here, I actually want to change this. Currently, this is just an integer, but F# has a nice feature called units of measure. So we could actually do something like that. Say this is actually 1024 GB. So in the future, we'll probably just add that into this field. Most of the other ones have that already. And that's a useful feature because then not only is it kind of a contract, but you can't give 1024 MB to something that wants 1024 GB. So it makes it that bit clearer. And we can, of course, change things like the size of the disk and the size of the CPU and so on and so forth. So we have a load of things there. If you want to run a script on deploying the VM, you can sort of say, this is the script I want to deploy. You can pass that in as plain text, or you can give it a list of files. So a reasonable amount of flexibility there. Again, does most of those things for us. I'm not really going to cover it today, but if you had a virtual machine, a virtual network, then you could easily attach this to the VNet. So we've got flags there for VNet as well. So there's plenty of ways that you can sort of plug these components together. As I showed you before with like the storage key and the web app, these are not kind of monolithic components. We try and make them so that you can compose them together as you need to as well. I'm just going to change this app. So rather than actually writing it, I'm going to change to deployment. And this is going to fail again. So I'm going to say execute, and then the name of the resource group. So I'll say Copenhagen. And there are no, I'm going to leave this as an empty list, which is the parameters that are required by the template. So if you were paying attention before, you'll realize this isn't right. I've missed out this parameter. So there you go. It actually says the following parameters are missing. Password for Isaac VM. Please add it. So I actually have to pass in the password here. So password for Isaac VM. And the key is that, and then the value would typically be the password that you want to set. So, you know, I might make it QA, something like that. And that will get threaded all the way through the template and actually deployed into Azure. In the interest of saving time, I'm going to leave that one out, but believe me when I say that works. What I'll do, though, I'll just demo two more things, and then I'll switch back to the slides and we can talk again. So one thing we can do is I'm going to add in the storage account and the app. So one thing we can add into an ARM template, and this is particularly useful if you have a pipeline for your build or your deployment that extends outside of the lifetime of ARM, is that you can also add outputs. So I can say output, I don't know, let's say storage name. In there I can say storage account dot, let's my storage dot, and I can pass any of these parameters, these properties, as outputs. So I could say I want to get the key back out after the deployment is generated. And then here I will get back parameters, outputs. Just that. And this is just unfortunately it's a weekly map, a weekly type map, but I could then say storage name. And that's actually a very poor name because it's actually a key, but you could get that back. And then you've got your storage key without ever having to actually have typed it in or looked at the portal. You'll have done a deployment, got the key back out, and then you can carry on with the rest of your build pipeline. So maybe you want to seed your storage account with some data to get up and running. And this is, again, a very common pattern. I want to create some resources, put some default data in it when I've created a brand new environment. This sort of stuff makes it relatively seamless to do that. I'm just going to stop that. Last thing I'll show you is how to do a full app deployment as well. So let's leave that. Don't need that password anymore. So imagine that we had a web app, an ASP.NET web app, and we wanted to deploy it. So as I said before, most of the portal doesn't really give you great support for this, and ARM templates don't support deploying code and infrastructure into the app service. ARM templates just don't support that. But in Pharma, because we also can push out to the Azure CLI if we need to, we can do this. So I can use this thing called zip deploy. And if I've got a web app that I've already sort of built and published locally, I can literally just give it the path to that folder. I can say code. I mean, let's see if I've got a web app over here. I've got a folder called web app. Let's have a look what's in there. Yeah, and deploy. This looks good. So let's try that folder. So I'm going to say users Isaac. And that would theoretically then bundle up that folder built by .NET, but this doesn't have to be a .NET app. It could be any web app that is running, that can run an app service. So it could be a Node.js app, it could be a Java app, it could be anything like that. And it will essentially do the whole thing in one step. So you can go from literally nothing to an entire fully deployed and configured application. So if you imagine that this app needed a storage key as an environment variable, well, that's not a problem because we'll set that at the same time as the deploy. So you can literally go from nothing to everything in one step. And I'm just going to risk it. I'll actually leave this running, but then I'm going to run back to the slides and we'll see if it's actually deployed. So let's try that. We don't need this. And I'll just leave this running, but you'll just see here at the bottom, you'll see we've got now, we've checked which version of Azure client we've got. I've logged in with a subscription. I'm now deploying the ARM template. This may take a minute or two, or in this case, what have I got wrong here? Invalid template. Probably the, okay, Isaac storage is already taken. So that's pretty reasonable. Someone's already used that name. So let's do Isaac Copenhagen store. Let's do that and Isaac web, and let's just put one at the end in the hope that someone hasn't used that name. So unfortunately, there's no way for us to really check that in advance. These are global names that you can't really know in advance if someone's used them or not. But either way, you can see that we're sort of wrapping around here the Azure client. I'm doing deployments, we're parsing responses, and so on and so forth. So I'll leave that running, and then I'm going to jump back to the slides. Again, if anyone's got any questions, please feel free to ask them at this point. Right. So, just as an example as well of how that VM sort of code looks. So this is literally the 3 or 4 lines that you need for a VM. That explodes into over 100 lines of ARM that you have to know exactly how to do. So just to wrap up in terms of kind of use cases for Pharma, kind of 3 or 4 ways you can use it. So one, if you're just happy with your current pipeline, you're using ARM already, and you don't feel comfortable switching over to Pharma for the entire pipeline, well, that's not a problem. You could use Pharma to just author your templates, and you could do this in one of 2 ways. You could say, I'm going to use Pharma as my local dev tool, but I'll commit my ARM templates into source control. That's one option. Second one is you could say, actually, I'm not going to even bother deploying, committing my ARM templates. I'll just commit my F# app. And as part of my CI/CD, I'll run the app to generate the ARM template. So the ARM template becomes almost then a kind of ephemeral file that doesn't really live long. It's just something that gets deployed into Azure. You could also use Pharma to deploy as well. So your CI/CD can actually just run the Pharma app and then use the deploy SDK as I showed you. Use it as part of a build script, no problem. Yeah. Or the other half of it, use it as part of a running app. So I've got a running .NET application. I want to then pull out to Pharma to generate and deploy a template and then come back and do something else. I think it's worth just touching on some of the benefits we get by working on .NET. And I know you can think of this more broadly as the abilities and the benefits you get by working on a full development runtime platform, as opposed to ARM or Terraform or Bicep, which are very different in that regard. Is one, you get a proper, what I would call a proper programming language. So I certainly didn't have the time, and none of my team had the time, to develop an entire language and compiler for Pharma. So that's not a problem. We use an existing one called F#, which has things like a compiler. It's got IntelliSense, it's got a type checker, it's got NuGet packages, which is part of .NET. You know, there are hundreds of thousands of NuGet packages. So if you want to pull down a package to do something as part of your build, well, no reason why you can't do that.
Isaac, you went totally right.
Yeah, I managed to mute myself. Sorry about that.
Fair enough.
I just realized I'm back. So we get IDEs like Visual Studio or VS Code, whichever one you want. You're not tied to a specific one. You get refactorings out of the box, so like rename refactorings, IntelliSense. All of these things are things you get for free by using a language that's got a compiler and a rich ecosystem about it. A lot of flexibility. So I'll actually just jump back in just to show what I mean by that in terms of flexibility. So that actual has worked, that code, but I'll jump back in. If I want to make 5 web apps rather than 1, well, I can do that as well, because F# has something called list comprehensions. So I can say for I in 1 to 5 do, and then I can say this, and now we've got a list of web apps, and here I can yield them back out. And this should hopefully work. This just has to be. So now we can programmatically create resources based on arbitrary arguments. So we can now dynamically create resources. This sort of is sometimes challenging, if not impossible to do in other sort of environments. On the other hand, we didn't want to give up the benefits of ARM. So you get things like the Azure CLI, which is a really nice way of deploying ARM templates and controlling them. We get the Azure portal, where we can see what's happened with an ARM template, and I'll jump into the one based on that deployment I just did. We get visualization tools, like you just saw, for that's graphically showing the templates, and we get the whole deployment stuff. So I get this idempotent deployment and this API that Azure sort of supports and gives me. So I'll jump into the browser and just open up the portal and find this deployment that I've just made. So let's go back to code, and I deployed it to a resource group called Copenhagen Demo. Resource groups. There we go. So there's the resource group, Copenhagen Demo, and I've got my resources here. I can also look at the activity log, so I can see what's happened here. I can look at deployments, so I can see here's the deploy that I did just a few minutes ago. I can look at exactly what happened. I can see the inputs, the outputs, the actual template that was developed. So I can actually effectively do everything that I normally would do with ARM templates, just without the pain of having to manually craft this template. And indeed, if I go back to the web app, you'll see that we've got in the configuration element of the web app, I've got all these settings, the storage key is there, so I can look at that and I can actually get to the secret storage key. I can go to App Insights and I can see that it's been correctly configured to connect to the App Insights instance. If I go to the terminal or the console, you'll see here, if I do a quick directory, that all my files have been copied up as well. And let's, I have no clue what that app was, but I'm going to risk it and try and browse to it. Let's see if we get something running here. So this is the first time I've kicked off the app, and because it's on the free Azure SKU by default, it takes a minute or so to spin up the time. That may well crash. It depends on what it was supposed to be doing. I suspect it was. Oh, there we go. So we get a hello. So there's a real app that I've deployed, ASP.NET Web App, written in F#, that's been deployed from scratch using Farmer. Let's jump back here. I think we've got just a couple more slides and then we're done. So yes, Farmer uses F#. So what you saw today was a very, very high level or abstract view of F#. So for those of you that are kind of F# curious, I would say what you're seeing here is something that is designed, it's a DSL that's designed to appeal to people that maybe either A, don't know F# or B, don't know .NET at all, and they just want to use it as a means to an end to generate ARM templates. Maybe they're familiar with ARM templates, hence the curly braces. But F# is a full first-class citizen of .NET. So you can do pretty much everything that you would do in C#, plus a whole bunch of things more. So you can do interfaces if you want, you can create classes if you want, but it kind of, in a nutshell, it flips it over to using things like records, pattern matching, pure functions, things like that on .NET. So to my mind, it's kind of the best of both worlds. Don't believe the FUD about F#. It's really not difficult. The hardest thing you will find if you're coming from a C# background will be forgetting the kind of patterns that have been almost hardwired into our brains. That's pretty normal. It took me 3 times the first time I was learning F#. That's because it was a few years ago. There really weren't many good resources. There really are good ones now, though. So don't let that hold you back from trying out F# and from trying out Farmer. Just a quick question there. So what's the popularity of Farmer now? It seems like the best way to define and deploy Azure services. Does the ordinary C# developer see the advantages, and are they willing to use F#? So kind of 2 questions there. The popularity, I can't really give numbers in the sense that we don't track downloads or usages of Farmer. Certainly it's becoming a bit more popular in the sense that there are more people using it now that we see contacting us for support. I'll show you the GitHub repo where you can see the number of contributors onto the repository. I'm seeing Microsoft talk about it a lot more now, which is obviously great to see. So I can't really give you any numbers, but certainly it's, I think, a more accepted way than it probably was 18 months ago, particularly as Bicep is, in a sense, it's a similar technology or approach. It's a compiler down to ARM. So this kind of approach seems to be working well. If you're looking to use F# as a means to an end to use Farmer, you don't have to give up C#. You can reference F# assemblies from C#. So you could just as easily have a method in F# that says create my resources and call that from C#. It will just look like a static class with a static method on it. In general, I'm a big fan of F#. I built a whole consultancy on it because I really think it's a better way of writing the majority, I would say 90% of languages, 90% of solutions that we typically have done, line of business apps, web apps. But that's my personal opinion. Obviously, everyone has their own thoughts about that. I would say there's really no reason not to try it, particularly if you're using .NET Core. F# is already in the box. It's got support in Visual Studio out of the box. Inide is a great extension for Visual Studio Code. Give it a go, I would say.
Yeah,
so
I just have a comment with regard of the.
Yeah.
With regard of the. Oh, Isaac, could you please mute me? Otherwise, I hear myself. Yeah. So the concept about F# versus Bicep is that F# is like a .NET programming language, right? So you can see that everything that Isaac just did, he was just coding F#. So it's more or less like the C# script, right? Compared to PowerShell. The good thing about C# script or F# script or F# as a language is that you can actually use all the tools, all the components, all the libraries that you are used to. You can see that you can easily do a loop. You can easily create a lot of elements based just on the language, right? So I find that really approach when I do these ARM templates because, I mean, I'm just coding, right? So it's just infrastructure as code, as Isaac has in his website. Infrastructure as code done right. So I just wanted to leave that comment.
Thank you. Thanks. I like that. And yes, I'll agree. So I think the biggest issue with there's a question actually now. It's probably a good time to maybe segue over to that. So let me just jump forward a couple of slides, and then I can answer this question. So touched on this already. Yeah, fine. There's a question about Bicep, which I'll come on to in just a minute. And there's another question about rather than just going to ARM. So I'll come to that in a minute as well. So just on the ARM side, what can't Pharma do? Some of these are by design. Some of them are just we haven't got around to it. So we don't support arbitrary parameters. We don't really want to. If you want to parameterize your template, we see it as parameterize your F# code instead, and then generate your template. That makes things a lot simpler. The only parameters we do support are the things that you saw, things like virtual machine passwords, where we want to explicitly force you to parameterize them. There's no need for variables. You can do that within F#. It's just let x equals 1, 2, 3, and there's a variable. Linked templates is something we don't support, and we haven't really seen any demand for it, so we're not going to really at the moment. And we don't support every feature of every resource. I'd love it if we could. The truth is, we think 80% of most resources, rather 20% accounts for 80% of the use cases. So most of the time, we see people just using a few fields again and again. And then occasionally, a few months later or weeks later, we'll see someone say, oh, could you add another field on? And we'll do it, or they'll do it as a PR. So we really wanted to cover a broad set of resources relatively quickly. So future plans for Pharma, yes, we want to create more support for more resources. We already support around 100. We're thinking about looking at something similar to Bicep in the sense of sort of code generating based off schemas. I'm not so fond of this idea yet because of the same concerns I've got. The schemas are not really fully compliant and they don't support everything. So I'm not really sure. Part of the idea of Pharma was to create these really beautiful abstractions that are easy to work crafted, which is kind of a pro and a con. It depends on which way you want to go. Subscription level resources, so being able to deploy resource groups themselves and subscription level items. More validation. I didn't really show, but we do have a decent amount of validation. So we'll check things like storage account names, if they're actually proper names and meet the validation requirements. Reducing errors through types, those sorts of things. But we do want to stay pragmatic. We don't want to make this Haskell style thing where it's like type it to the max. Make some small changes to the API. Probably that will happen in V2. And we're considering, probably at a commercial basis, making custom-built modules that make it easy to generate data that goes into ARM templates. So if you're using ADF or Logic Apps or Azure Active Directory, you can embed into an ARM template, almost a DSL, but it's weakly typed in the ARM template of what your pipeline is going to do. And we're thinking about investing into that, but we're not sure yet. And maybe this notion of what we call live reference data. So this would use a feature of F# called type providers, where we would want to give you IntelliSense of live data as code. So the ability to say, I want to create a VM with this image, and you could dot into the marketplace. So you could say VMs dot, and then get a live list of images that are in the VM marketplace in Azure. Pulumi and then Bicep will be the next one. So Pulumi is a cross-platform and cloud technology for deploying infrastructure. It's really impressive. Big fans of it. I really like it. Definitely try it out. I wouldn't say Pharma is a direct compete. Yes, there are a lot of similarities. Pharma is single platform. Pulumi is not. Pulumi is not coupled to ARM templates, so it does its own sort of state management, whereas Pharma lives on top of ARM. Pharma is a single language, F# only, really. The flip side of it is Pulumi is the SDKs are auto-generated, so they're almost at the behest of what the schemas that Azure generates gives them. Whereas with Pharma, we want to make handcrafted templates that really fit nicely. So it's pros and cons there. Bicep, which is obviously one of the questions there. Well, what do I think about Bicep? So one, I think it's definitely a step up. It's a slimmer version of ARM. So it gets rid of a lot of the boilerplate, which is good. It's a one-to-one mapping between ARM and Bicep. So that means Bicep supports every resource that ARM currently does, because it is literally just a compilation into ARM with no abstraction in the middle. So that's a benefit and a cost, I suppose, in both ways. You get everything, but you get nothing on top of it. So it's definitely better than, I don't want to use Farmer or Pulumi. Bicep is a very, it's a safe bet on top of ARM, I would say. It's not a Turing complete language. It's not a full language. It's got a type checker of some sort based on the schemas, and it's got its own language. It's still an alpha. I think it's at 0.3 at the moment, and it was launched 8 or 9 months ago, I believe, or at least announced. So it's still, it's got a way to go. The reason why that's taking time is they are building a completely new ecosystem. It's a brand new language. So if you're using ARM and you think F# is going to be too hard to learn, well, if you're going to move to Bicep, you're going to have to learn that as well. It's a brand new language. It needs its own CLI tooling. So there's a new, Bicep command line tool you need to download. You need to get the IDE tooling, which is currently at least VS Code only. It's got its own compiler, its own parser. It's a brand new ecosystem they're building. Obviously, it doesn't have the integration into .NET like Farmer does. You can't hook it in programmatically. It doesn't have NuGet. It doesn't have a package management system or anything like that. That may come in time. I don't know, but it's a very different approach in that regard. Both of them boil down to ARM, but they go at it from different perspectives from the user. The other question I can see here was, would it be possible to render Farmer onto something other than ARM? So I've had a few people ask about this. Some people have said it'd be great if we could do this for AWS as well. Something like that. We're not really thinking about it in terms of that. There would be a lot of work you'd need to do at the very bottom to make it completely platform agnostic. Certainly the techniques that we've adopted here could be applied. And if you really wanted to, we could do that because we have a kind of an intermediary in-memory layer where we could redirect to something else. So we could do it. I don't think we're going to, just because I'm wary of the idea of these abstractions are based on optimizing for Azure. So if we had to make a common sort of platform across both Azure and AWS, you may end up with resources that are kind of suboptimal for either. A better approach would probably be to take the same kind of techniques and maybe extract a core library out of it that could do the mappings between top level and bottom level. Like I said, Farmer is opinionated. We don't really want to support everything in ARM. I don't think we'll ever get there, but I don't think we need to. We're basically targeting this 20%, 80% sort of flip side. It works for most of our customers. And on the occasions that we don't have enough, we're usually able to add extra resources pretty quickly. How do I get started? If you've not got .NET Core, you can install it today. So it's literally just Google .NET Core. It will be the first hit you get. Download .NET Core 5. It works on Mac, Linux, and Windows. So the days of .NET being Windows only are all over. Download Visual Studio Code and the F# extension, which is called Ionide, or if you're using Rider or VS 2019, there is also a template we give you. So you can say .NET New Farmer, and it will give you a basic app with the package already added. But as I showed you, it's really just .NET New Console or a script. I'll show you the docs and a couple of links in a minute. How could you get involved? So one thing is try it out. Give us some feedback on what you found. If there's missing resources or things that you need, things that you find confusing or don't work, all of that is good feedback. You could give more documentation. So we made a big effort to make sure that there is good documentation, but it can always be better. So feel free to add there. Share knowledge of Farmer with others, obviously. Pull requests if you want to. Totally fine as well. I touched on this before, so it'd be remiss of me not to do it again now just to round up. We do have commercial options, so if you want to use it for free, go ahead and do that. We obviously don't suggest using it for production use, just in case you do have problems. The only support you'll have is GitHub. We may or may not answer that. If you want something that's a bit more than that, then we offer decent different levels, which are appropriate depending on how you're using Farmer, what your team size is like, how complex your templates are. Obviously, the more commercial investment we get, the more likelihood we have of continuing to invest in the product. I'll do a couple of links now. So let me just open 2 or 3 links here. So let me just open up this one. So this is the Farmer homepage. So yeah, there's some blurb on the top. On the left, we have basically every single resource we support and child resources with kind of a full set of examples. So search, for example, tells you the keywords we support, some configuration members, and usually a sample. We also have some quick start guides, so how to get going up and running, tutorials. So how do I do certain tasks with some guide and walkthroughs, and we're continually adding and evolving those things. We have a kind of how to contribute as well, testimonials. So there's a bunch of things. Obviously, some of from our internal team. We've had over 300. There's still a growing number of issues, which is a good sign. People are using it more. Yeah, and it's got a growing number of stars as well. So yeah. If you're interested in F# in general, then docsmicrosoft.com, yeah, .NET F#. You can sort of go through this. It's, like I said, it's not really, in my opinion, a difficult language. If you're not coming from an FP background, then you might find some of the concepts different. If you're coming from a Scala background, then the concepts are pretty similar, except there are no type classes in F#. And the syntax is more from the Camel, Haskell, ML style background. I think one more slide and then I'm done. So let's jump back on here. Spoke about all of that. So yeah, last slide was just a thank you. If there's any questions, now's obviously the time. Otherwise, you can always email me, isaac@compositional-it.com, or on Twitter, where as long as you're willing to put up with the occasional tweet about Tottenham and how bad we're doing at football, then feel free to follow me as well there. Otherwise, I'll hand back to Ramon. Let's see if we've got any questions here.
Yes.
Yes.
Thank you for that.
Thank you for that.
So I don't really have like a screen, so I can just do like this. We go all dark. Well, I probably should have some. Just a second. Yeah, this one.
There's probably one more question. If I could just answer that one quickly.
Yeah, sure.
Cool. So one question was about escape hatch, and is there an example of that? So let me just jump back onto here and see if we've got an example on the actual website. If not, then I can show you a video on YouTube of it.
Yeah. So if you share your screen again, then people can see it, because right now they just see my.
Okay. So let's share again. Screen 2. Is that working?
It's probably taken a bit. Oh, just a second. I'm going to move the screen again. It's still mine. I can still see mine here, like the terminal.
Oh, I am sharing. Maybe we've lost it now then. Never to come back again. Nikolai, the escape hatch example.
Yeah. Oh, I was just covering your screen, sorry.
Oh, right, okay.
Sorry about that.
No worries. So escape hatch examples. So there's kind of 2 or 3 ways you can do that. So one is inside the Farmer namespace, inside farmer.arm, we basically have access, rather than these kind of high-level configuration sort of keywords, and sort of builders, we have access to the low-level resources. So if I want to create a storage account, for example, you'll see we actually have like the low-level storage account object here. So this has got like the name, the location, the SKU, the dependencies, and other properties. So you can go right down to the sort of the low level. You have to do everything yourself, almost at the, you're still strongly typed, but you'd lose that kind of high level abstraction. So like for a web app, you could build it by creating a server farm manually using this record syntax, building all the other bits yourself. That's one way. The other way you can do it is in Pharma, we basically support the ability to create your own builders, basically. So I'll just see if I can find the syntax here. ARM builder, JSON. Let's see if this is the one. Yep, to ARM resource. So here you can effectively create any ARM resource by literally copying and pasting the code from a real ARM template into here. So if I want to take, for example, let's see if I can find a storage account one. Okay, I've just got the VNet. Oh, there we go. So an IP address, for example. So I could, if I really wanted to, take that code, paste it in here, and that can now be added into here. Or at least it should be. Add resource. There we go. And then you could step-by-step build up from here. So I could say, actually, now I want to parameterize this based on a name. So I could say, let's make this name, and now that's name. And let's call this IP. And then down here, it would be make IP Isaac. And now slowly, you can start to transition away from ARM to using Pharma, but still start to break out into more and more code as you go through. And there's a kind of a walkthrough in the guide here into deployment guidance, contributing. So in the contribution page, there's basically an example of doing that and how to create one. So we basically take an example and we step-by-step sort of build it up over time. So you can see here, created kind of strings and embedding stuff, and then you end up with a builder. So that's kind of the escape hatch if you want. Right, now I think I am finished, Ramon, so yeah, back to you.
Yes, so I will just showcase this image that I made based on all the talks that we have for the last, what is it, already 8 years. And it didn't, we really didn't need to do anything with regard of 2020 because 2020 was just crap. So this is why we're trying to make 2021 a little bit less crap than 2020. So this is why we are aiming for these online virtual talks. So I hope you all found that it was a really good topic. I find it quite interesting, the farmer concept at all, because I'm using it on a daily basis, and the amount of time that tool saves me so I can do productive work, that's actually insane. So this is why I also try to ensure that many more people in Denmark are showcase this amazing tool done by Isaac and his co-workers. So yeah. As I say, we will try to make more of these virtual talks every month, just so we can still try to preach a bit about functional programming. And of course, if it's goes hand in hand with the Scala community, well, then we will try to reach out to those. And if it's .NET related, we will try to reach out to Azure and, of course, the .NET user group in Copenhagen. So I think that's pretty much it for today. So unless anybody has some questions, I think we will close down the stream. Yeah. So yeah, I can see people applauding. I don't know how to do that in chat icons, but hey.
Thanks again, Ramon, also for the opportunity and the invite. Thanks again.
Sure.
And
I will just cut the stream, and we can just talk a bit. So cutting the stream now.